In this video, I will show you how to use z-scores to find the percentage of data above or below a certain given value. In 1999, the scores of men on the math part of the SAT followed a normal distribution. That means a bell curve like this, with a mean of 531 and a standard deviation of 115. What percentage of men scored above 500? So first of all, I recommend organizing your work in the following way for this type of problem. Divide your space into 4 quadrants. We're actually going to have 2 graphs. Okay, so I mean, obviously I'm cheating with the cutting and pasting, but you would need to just draw little sketches. So in the first curve, we're drawing SAT scores. This is the distribution of SAT scores. So let's label that SAT scores. The second graph is where we will convert from SAT scores over to z-scores. And to do that, we will use our z-score table. So you've got to have one of these to do the problem. So if you don't have one of these, Google it and get yourself one. Okay, so let's go ahead and write the information that we have. So the mean is 531, the mean SAT score. So that's going to go right here. All right, this middle line represents the mean. All right, 50% of the data above, 50% of the data below. Okay, we don't need the standard deviation yet. What percentage of men scored above 500? Again, this 500 is an SAT score. Now, that is less than 531, so I'm going to go ahead and put that number over here to the left. Okay, so here's my 500. Now we want to know what percentage of men scored above 500. So we're talking about the percentage of data that's to the right of this 500. All right, so it's the yellow zone that we're looking for. Now we're going to use our z-score table because our z-score table tells us the percentage of data to the right, to the left of any z-score. Okay, it doesn't tell us about SAT scores, but you'll see that we can match them up. We can, for any SAT score, we can translate that into a corresponding z-score. So we need to find out what this z-score is. So that, you know what, let's go ahead and do that right now. If you want to find a z-score, if you want to convert from any value to a z-score, what you do is you take whatever value you have, whether it's SAT scores or heights or whatever it is, and then subtract the mean and then divide by the standard deviation. That's how you do it. Okay, so in this case, our value is 500, and we're going to subtract the 531, and then we're going to divide by the standard deviation, which is 115. Okay, this fraction is not going to help us. We need a decimal. So be careful how you round. We need to round this to the nearest hundredth. That's 2 decimal places. Okay, so we want to cut it like right here. However, we are not going to simply say negative 0.26. Oh no. If the next number is 5 or higher, you need to round this number up. So since this is a 9, instead of saying negative 0.26, we're going to say negative 0.27. So negative 0.2. Whoa! What was that? It just... Okay, so that happened. Anyway, it's negative 0.27. My screen is going crazy. Guess I don't know exactly how all the features work. It was actually kind of cool. Okay, in all that excitement, I think I forgot what the number was supposed to be. Negative 0.27, I think is what we decided. Yeah, got to round up. Okay, so we have found the z-score that we were looking for. So I can erase that question mark. And we now know that it is negative 0.27. Alright, so these sort of match up. By the way, any z-score graph, this middle number, the mean, is always represented by 0. 0 is right here in the middle. So any negative number is going to be below the mean, negative z-score. Any positive z-score would be above the mean. 0 is the mean on a z-score graph. Anyway, so our next job is to figure out what percentage of the z-scores are greater than negative 0.27. Our z-score table, unfortunately, is not set up to give us percentages to the right of a value. Look at this little picture here. All of these numbers on the chart are percentages to the left of any z-score, not the right. So we have to be careful. We can still use this chart. These are numbers, these are percentages that are below. But for example, what if we found out that this shaded area represents 80% of the data? What percentage of the data would be represented by the white part? If this is 80% shaded, the white part is what percent? 20%, right? 80-20. You know it has to add up from 100 to 100. So we can use these values, but because we want the area to the right, we're going to have to subtract from 100. If this is 60, okay, which we find off of the chart, what percentage will be to the right? If this is 60, what will this be? 40. We have to subtract from 100. So that's exactly what's happening now. The chart will tell us what percentage of the data is to the left of this number. We're going to have to subtract from 100 to find the percentage of the data to the right. Okay, so let's do that. If we want to find the percentage of z-scores that are above negative 0.27, like I just mentioned, we're going to have to subtract from 100% whatever we find on the z-score table. So here's how we do it. Remember this number, this z-score, negative 0.27. We need to find that z-score on the chart. Now these are all positive, so I'm just going to scroll over to the negative side. So here are my negative zeros. Here's my negative 0.2. Now I want negative 0.27. So look at the top here. This column is the 0, and then 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7. This is the column that I want. So you can't see it anymore, so we're just going to have to remember. So negative 0.2, 0, 1, 2, 3, 4, 5, 6, 7. Okay, so this is the number that we want. Now the decimal 0.3936 is the same as the percentage 39.36%. Okay, So that's the percentage to the left, 39.36. To find the percentage to the right, we need to subtract this from 100. Okay, 39.36. I have a horrible memory. So let's subtract this from 100. %60.64%. Okay, so that is the percentage of z-scores that are to the right of this z-score. Okay, so over here we've got 60.64%. All right, so let's go ahead and translate that into a sentence. Okay, whenever we do a real world problem like this, we should answer in a complete sentence. Okay, here's the final answer in a sentence form. However, I remember that I'm sort of skipping a step here. This percentage is the percentage of z-scores to the right of this z-score. But what about SAT scores? I'm taking for granted, but I forgot to mention that these percentages are the same. Okay, that's why we can use z-scores. That's why they're so helpful, because we can convert over to z-scores so that we can use a chart like this to find the percentages that we need. But the percentages will be the same percentages for the SAT scores or whatever kind of data you wanted. So the percentage of the data to the right of 500 is the same as the percentage of the data to the right of the z-score that we got from 500. So, in other words, 60.64%. So that's why I can say 60.64% of the men who took the SAT in 1999 scored higher than 500 on the math part. That's the final answer. Now, before I turn off this video, let me just mention to you that we had to subtract from 100 because we wanted the percentage to the right, but our chart only gives us percentages to the left, so we had to subtract from 100. But just remember, on another problem they might ask us for a percentage that is below a certain number. If this question had said what percentage of men scored below 500, if it had said below, then we would have wanted the part to the left. In that case, the answer would have been the 39.36% that we got right off the chart. Okay, so I'm just trying to emphasize to you that if they ask you for the percentage of data that's less than a number or below a number, you can just read it right off the chart. You don't have to subtract from 100 unless they say find the percentage above or greater than a certain number.